How's everybody doing? You good? It's 11 o'clock. Everybody put your hands straight up in the air. Come on, everybody do it. See how you can do anything you want when you're on stage. You can make people do whatever. It's great. At least you got the numbness out of your fingers. My name's Jason, and I'm here to talk about stuff. Why am I here to talk about stuff? Well, I'm going to be talking about data science, and I'm going to be talking about analytics and why those two things can be applied to API flows. So the data that's moving across API transactions. If we look at it from an analytical perspective, we can actually see vulnerabilities being exploited. We can see people doing nefarious things. So I'll tell you a real quick story. My son calls me and he goes, "Dad, the fraud alert on my bank account is going off." And he was getting text messages from the bank saying, "We stopped fraud, we stopped fraud, we stopped fraud, we stopped fraud." So I went and looked. I have access to his bank account, and I went and looked at it, and there was a $35 transaction on Delta Airlines for international Wi-Fi. Why? Can anybody tell me what just happened? Because I had to figure it out. My son went to a gas station and he put his debit card into the gas pump. His card got skimmed. They took the number and they went and bought Wi-Fi with it. Why would they do that? Any guesses? Maybe. Any other guesses? Does the card still work? That's really what they were doing. How are they doing it? Well, when you log into any of these airlines and buy their Wi-Fi, you're using an API. So if you step off the plane and you still know that API endpoint, you can stick a credit card number in there and see, does it work? So it bought $35 worth of Wi-Fi, international Wi-Fi, whatever that is, on Delta, but it drained my son's checking account because he's my son. And in the States, I'm known as the guy that they put on TV at Christmas time, and I sit there and say, use a credit card, because debit cards can drain your bank account. Credit cards have backstop limits for merchants. Always use a credit card online. My son doesn't have a credit card, he uses a debit card, but when he buys anything online, I buy it, right? So that way it's a lot easier and safer. So somebody had the API endpoint for Delta Airlines, and they're using that to validate credit cards or debit cards, whichever. When they did that, it took all the money out of his account, and so when they tried to do the next transaction, it didn't work, right? And that's a lesson right there. That first transaction works. If you drain a bank account, the second transaction doesn't work. So we're going to talk about the analytics of that. So my name's Jason. I've been doing this a while, about 26 years now. I've been throwing tick marks at websites. This is a white hoodied hacker throwing tick marks, according to ChatGPT. You'll notice there's semicolons. I couldn't get it to do that. I've been doing research in APIs for quite some time. Various responsible disclosures. I have a garage door opener on my house that didn't come with the little clicky box, you know? It came with an app. And I opened my garage, and a buddy of mine had bought one of these. He lives about 2,000 miles away from me. I opened his garage, and he said, "How are you doing these things?" And I said, "APIs." So now I work for a company called Traceable. I'm a SE overlay. I do bot and fraud stuff. I'm going to have to ask you guys to give me a little bit of grace. Anybody that's in here that follows me on LinkedIn knows I had an explosion in my house, blew up my basement, incinerated most of my guns, and I was about 40 seconds away from being incinerated myself. I had lit the pilot light on my water tank, and I walked upstairs to tell my wife that the bath won't be cold in a few minutes, and the house exploded. It didn't quite blow up like this. This is a still frame I got off my security camera. It's my back door flying past my back door security camera. It blew out the door and two panels next to it. It was 12 feet wide, blew it all out into my yard, and that's what saved my life. When my builder built my house, they only put 4 nails on each side of this. And if they had done their job, the house would have blown up completely. Firemen told me that normally when they roll up on these, it splinters and dead people. So when something tragic like this happens to you, you have to go lean on those that you can find comfort in. And so I used to be in the Navy. I was on a submarine, so I have a chat group with a bunch of my old submarine friends, and I told them about my house blowing up, and this was crazy. And firemen, and the house caught on fire. We lost most of the stuff we owned, and they said, "But did you die?" So that's the attitude I've started to take. And this is a famous submarine thing. When you tell a story, they always ask you, "Did you die?" I didn't, but I have a new way of looking at things. So we're going to talk a little bit about some of the attacks that can happen out there, and some of the things that you'll see in APIs. Things like banking. Oh, I'm on the wrong deck here. Dang it. Sorry. I have a very similar deck that I was doing something with earlier. All right. I'm still here. So we're going to look at understanding the different API endpoints that are out there. We're going to look at kind of some of the ways that we can use analytical strategies on these endpoints to understand what's happening, right? Like the original story I told about my son's credit card getting stolen and them using an airline API to validate the card. There are analytics that you can apply to these things to figure out, are people doing nefarious things against you? I'm going to talk about data science. Anybody here going to school for data science, data analytics, anything like that? Yeah, a couple, good. And then we're going to talk about what vulnerability research looks like using analytics, and we'll talk about stopping the attacks. So there's all kinds of API endpoints out there, right? There's search endpoints, there's login endpoints, there's endpoints that go to infrastructure. There's all kinds of different ways that you can approach APIs for an organization. You guys are aware that there was a telephone company here that lost some data. I know you're all sick of hearing that, so I won't mention them. But that really did happen, right? Somebody pulled a bunch of data out of a database. In a taxi on the way over today, and this is an interesting thing, everyone's in cybersecurity now. My Uber driver was telling me he's in cybersecurity and was talking about how he attacks different things. And I said, well, that sounds great, but I can just go in through the APIs and pull the whole database out, right? Especially if you're using something like GraphQL, right? Where the calls are very big and they allow for you to extract a lot of data at once. And so as an example of this, I'm going to talk about this company called Fly.io. Does anybody know these guys? You do. You're the first person I've ever given a talk in front of that said they know who this is. All right, so what am I going to do with this? Well, I'm not going to deploy servers or anything like that. What I'm going to do is some research on this company. And the first bit of research that I'm going to do is just simply put API dot in front. And you can see from this, or maybe you can't, 404 error. What happened? I made a request to api.fly.io and I got a 404 error. What has happened? Well, DNS worked, right? Because we know we can go there and request things, but I didn't give it a path. There's no index, so it didn't give me any base information. It just said the thing you asked for on the server doesn't exist, but the server does, right? Or as I like to say, there's a there, right? So now let's try to pick that apart a little bit. And so what I'm going to do is I happen to know, but I'm going to guess, do they have a GraphQL endpoint? And I just simply put in a path GraphQL, and you see what loads. This is their GraphQL Explorer environment, or whatever you want to call it. You notice on the side here, it says docs and schema. This is everything about this instance. This isn't a vulnerability. There's a demo site for these guys. I'm just showing you their demo site. But what did I just do in order to get there? Well, I guessed that they might have an endpoint hanging off of a DNS record for API, and I guessed that they might have a GraphQL endpoint. I guessed, and look where I landed. This is called inference scanning to all of your vendors out there, right? They make an inference that things would be there, and then they test to see if they are. So we figured out that there's a GraphQL endpoint on the end of this. We have access to all of the docs in the schema just simply because it's there. So what's that got to do with analytics? Well, attackers are going to go look for your endpoints. They're going to try to find them. I taught a class a few years ago for OWASP on how to decompose APK files so that you could find API endpoints on the end of them. So think Android applications have this big text file of where all of your endpoints are, which is pretty nice. You can set up a reverse proxy on a lot of iOS apps. Most Android apps, this won't work because you get stuck with certificate pinning, right? Anybody here mobile app pen testers or do any of this kind of work? No? One in the back. Now you got to know Corellium. Corellium has this really nice service that they put together that allows for you to sit on bare metal and run your own certs. So certificate pinning no longer is a problem. It just goes away. It's nice. You can also look at web applications. A lot of times when you download a web application, that means you go to www.whatever and it comes to your computer. You can just open it up and look at the content APIs. Where's it going and getting things, right? There's a lot of this activity that can go on. And believe it or not, this section here is where all the really fun stuff is. There's API keys in there. There's a bunch of different kinds of endpoint describers. You can gain a lot of information from understanding how do you name things, what do your variables look like, right? That's why you should use ChatGPT for variables because it's very random then and it's much harder to guess. It's really the only useful thing it does. Documentation is often hanging off these endpoints. And for years, I told people you should develop Swagger files for any of your APIs that you have. But I was very, very incorrect in not then saying, don't make them public, right? If I just go to swagger.json to a lot as an endpoint for a lot of these things, I'm going to find stuff out there, right? Developer documentation often has endpoints in it. So all of these different ways organizations need to protect themselves from attackers figuring out where their endpoints are. You also have to really understand that a catalog of these things, right, is going to lead to vulnerability discovery. If you understand that there are people touching your login, that are touching your verify account, that are touching your GraphQL endpoint, right, then you understand people are touching your environment and maybe are doing it in ways that they shouldn't, right? How many of you know that there's a thing called XML-RPC.php on every WordPress instance, right? So how many of you get scanned for XML-RPC.php? How many of you have had to respond to a researcher who has found your XML-RPC.php and they want to charge you money because they found it? I have. I've paid that ransom. And it's dumb, right? So you can sit there and see, these are our active endpoints. These are the things that we really care about. So that means we should be looking at this for, is that normal? Is V1 login normal for us? It could be, right? I work with a lot of organizations that it'll be like V27, right? But V23 is still on. Why? And you'll see that endpoint getting hit. I had a customer come to me and say, can you go look at this for me? And they were getting hit on this verify account flow. And I said, what is this? And they said, we don't know. We don't have that developer here anymore. And I said, okay, what's it do? Yeah, we're not sure, but man, they're banging the crap out of it, right? So I go look at it and I look at the traffic that's hitting it and they're iterating through email addresses. Put in an email address and it'll say things like rewards points available or things like that account doesn't exist, right? Error messages are important in APIs. And so now we've got this thing where somebody's banging on this and what they're doing is validating, are there email addresses that fit these accounts? So now I have a list of valid email addresses. What do I need next? Passwords, right? Which I'm probably going to get out of a breach for all those email addresses, I understand, right? So we have to understand which endpoints are out there. You need to track what you think is important to you. If you're a retailer, search might be something that's important to you. If you're using LLMs, escape paths might be something that's important to you, right? I might be injecting code that says, go look in your information catalog and the price for this item is this, right? Not tell me what the price is. So those kinds of things are the things that you have to really understand. Retailers care about gift cards. Retailers care about carts. Banks, retailers care about account info, right? What are the things that matter to your business? Because this is where you're going to have to start looking at things. The other things that you need to understand are what's contained in the data flow. What's actually in there? So if we look, are there headers that we care about, right? I work with a lot of phone companies, and phone companies tend to drop IMEIs or something like that in the header, so you can understand this is the device that's actually making the request. Why would I put in canary headers? It's to see what people are trying to touch, right? And it's what they rip out later. When I go test a site, I'm going to be ripping the headers out and seeing what happens. Maybe some of you know this, maybe some of you don't. If you go to a Jenkins admin console with no authentication header, you are the admin. You just need to take the header out, right? If you're instrumented so that you can see that activity, you can stop it. Things like cart creation, right, for retailers or anybody that's doing hype sale information, anybody that's interested in high-speed sales, cart creations are important. Cart updates. This is how everybody steals stuff, right? This is how everybody beats you in a hype sale. Arbitrage has kind of gone away, especially for us in the US. You know, during the pandemic, money was free. And so everybody was buying shoes and then reselling the shoes. And there was this guy named Kanye that sold shoes. They're called Yeezys. Right? Well, Yeezys, for me, Yeezys were important for like 2 years because people were buying shoes like crazy. And then they'd list them on eBay and sell them immediately. And that kind of arbitrage is important. So why is a cart update important? Well, the way you buy shoes before someone else is you go there the day before and put a pair of socks in your cart. Then when you learn what the SKU is for the shoes, because you don't know it yet, you won't know it until it releases. As soon as you learn the SKU, you don't add shoes to your cart, you update your cart with the shoes and check out. Take the socks out, put the shoes in, check out. Meanwhile, everybody else is trying to get the shoes in their cart. See, you're a step ahead when you have a cart creation. So when you're looking at hype sales, the cart creation date's important. If it was yesterday, send them a CAPTCHA, right? Do something else. Origin IPs, origin countries. I often see Bob trying to log in from 19 different countries. That's weird, right? That's a very strange thing. And so you need to be able to get on top of that. So there's going to be some strategy to this, right? I can't tell you, you need to implement something right here. If you're a bank, that's going to be very different than if you're a phone company, than if you're a retailer, right? So understand what your analytical strategies are, but I'll give you a few examples, right? Go to your business goals and understand what it is you want to learn, right? You probably got a chief marketing officer that actually cares about what sites people are touching or what information they can get to. And so maybe there's some kind of top-end analytic that everybody's going to care about, right? They want to understand which flow is used the most. Login analytics and user behavior tend to run hand in hand. I'm seeing Bob from 19 different IP addresses that represent 16 different countries, and he's tried 28 different passwords. What's happening to Bob? Credential stuffing attack, right? Account takeover attack. And so understanding the analytics that goes along with this stuff makes it really easy to find. So where are the things that you're going to care about, and what are the things that you're going to apply these analytics to? Well, today we have kind of in our realm of understanding ML and AI, right? And ML is usually written in Python, and AI is usually written in PowerPoint. But what we're doing in ML is comparing two things. These two things look like the same two things all the time, and then suddenly one of the things is different. Bob goes from 18 different places, right? So that thing that's different is that Bob is trying to come from too many places. So we're going to do that in a bunch of different ways. We want to understand IP addresses compared to username, passwords compared to username, even if it's just hashes or jots. You're going to be setting yourself up to do these comparisons. And these comparisons are what are going to lead you to understanding your analytics. So this is an example of it, what a credential stuffing attack looks like. If you look at the peaks, the green peaks, this is a quick service restaurant. They're only open from noon to midnight or 1, and dinner time happens to fall right at the peaks. This is a fun little customer to work with, right? Because their traffic is easy. What the heck is happening right there, right? This jumps right off the page. An account takeover attack. They were attempting to rotate through a bunch of emails and a bunch of passwords to try to get through this. 5.75 million accounts were tested in this time frame, right? That's not very long. And you'll notice there's this little side bump here. That was when they started the attack and it was mitigated. And then they pivoted and started attacking differently and it was mitigated. The reality of this is when you're using analytics this way, you can see IP address, username, password, username, it leaps right off the page, right? And you can tell I'm under attack and this is how I'm under attack. So let's talk a little bit about how we're going to use that ML one, right? Because the AI one is harder. We're going to use the ML one. And so I asked ChatGPT, well, what is it that we should know? And this isn't a terrible list. It's not 100% accurate, but it's not bad. And if you start to look at your organization in this way, how can I detect anomalies? How do I see that Bob's trying to get his account taken over? How can I do some predictive analysis on behavior, right? What is it that you're supposed to do first and then second? If your very first activity is card update, well, then that's wrong, right? And you have to be able to trace somebody through the environment in order to see that. So when we look at this stuff, oftentimes we look at things that are simple, like user agents. How many of you are Edge users? How many of you are Chrome users? How many of you are Firefox users? Safari users, right? Firefox, Safari is the same thing. We used to call it Netscape. But if you look at how each one of these browsers gets updated, they get new versions all the time. Doing data analysis against a flow, you can actually see old bot writers, right? Because they use old versions that no one uses anymore. Again, leaps off the page. Mobile apps often have their own user agents, right? If I sit down and write a Python script to attack a site right now, the user agent's going to be what? Python, right? It's going to say Python in the user agent. If you're writing your own apps, change your user agents through versioning, right? So that you can understand this user came to us on version 27 and they hit this flow, right? You can understand that a lot better. Data science will help you find the good user agents, even when the population changes, right? Because as you could understand, data science is just the comparison of two things. So if suddenly Chrome up versions, which it did every day this year, you can see that as it rolls along, right? Similar to all of the other ones that are out there. So having these analytics is going to let you see this stuff, right? And then it also lets you see things like data conformance. Are the headers in the right order? Because bot writers are lazy and they'll just put it in any order, but you're not, right? So they come in an order. So you can see that stuff just jump off. JSON objects that all of a sudden are bigger, right, mean something. It means you are leaking data in some way, or it means that something has changed in your environment. Time to ask the developers what happened. What objects do you allow in the response? And when I say that, what I mean is I'm me logged into your system. Can I see your stuff? Right? Those are your objects, not mine. And so I need to be able to see what is it that I'm allowed to see. A lot of help comes along when you use things like Swagger files, open API files, because then you can see that stuff and you can understand what it's supposed to be set up like. I like to use canary URLs, right? XML-RPC.php is a great one. Set it up, make it look exactly like the WordPress page, and send it to them static. They'll end up running around like crazy trying to make things work. Auth token age. You know what computers do really well? Repetitive tasks. You know what's a repetitive task? Logging in, right? Using the same API keys for months doesn't make any sense. Your computers can log into each other, right? You can even set up certificates and all that kind of stuff to make sure that it's good. If there's an old token, time it out, get rid of it. That way, when somebody comes along with an old token, they're easy to see. So how do you stop this stuff? Well, a lot of organizations have implemented a lot of different ways to do this. But think about this for a second. If I'm going to block you based on your IP address, how long should I block you? For 2 years, my previous job, I couldn't get to this one website because they had blocked our Amazon IP address for our VPN. For 2 years, I couldn't go buy things from this website because they were blocking me. So what you need to do is ban the IP address and then unban it really fast. Because if somebody's attacking you in a hype sale way, an account takeover way, whatever that might be, they're going to be rotating IP addresses anyway. They expect you to ban their IP address. So banning the IP address is just simply blocking the next guy that comes along or the next gal, right? It has to be a completely ephemeral activity. You block it and move on, right? You have to let it happen again. But what if you could do it in a little bit more sophisticated way? So if the username appears in 4 or more IP addresses, it uses more than 8 passwords, appears with more than 2 different browsers at a time, when the traffic on the login endpoint is above normal, then block. That's analytics. That's data science applied to API flows. This is what we would call end blocking, right? Where you set rules that just stack on top of each other. Stacking logic, this allows for you to remove all those false positives. The very first thing that anyone's going to say, if you say, I'm going to block that traffic, they're going to say, no, 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 we don't want to block traffic, right? How many of you work for an organization that will not block traffic? What ends up happening is somebody gets blocked that shouldn't, right? I had that quick service restaurant. They block all, they're in Canada. So they block all traffic that originates from outside of Canada. And then one of their executives went on a trip and they were in Paris and they wanted to read the terms and conditions page off the website and they couldn't get to it, right? Because they were being blocked geographically. It's dumb and it was like an emergency request, right? The CEO can't see our terms and conditions. Can't order pizza, he's in Paris. All right. This allows for you to do a lot of false positive reduction, and you're going to have to figure out which flows this applies to and how it's going to apply. First step, inventory your APIs. Every security program says inventory first, and this is no different. You need to know where your APIs are. How do you do that? Well, it's not easy. You can do it through DNS records. Some really great stuff has been done here in Australia with Asset Node and Kite Runner to help you with this kind of thing. I work for an organization that happens to do this as well. Look at the traffic on those endpoints and understand it and start counting, right? How many times did Bob try to log in? Well, it was once today. Maybe Bob's okay. So where does it live? How do you bolt this stuff in? Well, you have to figure out where the traffic's in the clear because that's going to give you the most advantage in order to compare things. But things like passwords usually are very sensitive to folks if they're being passed in. So what you do is you take the hash or whatever that's coming in and count it. How do you identify new flows automatically is a hard one. So you have to be instrumented in a place where you are in the clear, right? On the flow that you care about, and you have to be able to see when a new one shows up. When your developer goes from version 6 to version 7, that's a new flow, even on your logins, right? Everything's going to change, and you have to be able to kind of react to it in a way that just keeps going. So you instrument for analytics. You have to be ready for a lot of traffic. I showed you that was about a 3-hour period where 5.7 million requests to the login endpoint came in. That's an interesting piece of traffic. It's an interesting moment in time. So what should the count be right at that moment? I probably could do this as like a blackjack talk, right? Tell me the count, because we need to understand what it should be. An understanding of the number of requests per second that your flow handles at this time of the day normally is important. Because if it normally runs at like 5 million requests per second and it goes to 50, that's important. Something happened. So there's other things that go along with all of this analytics. For instance, look at these email addresses. They're not user-friendly. They're not human-friendly. They don't make any sense, right? This is an actual use case where an organization had free server time. If you sign up today, you get like 2 hours of free server time. And you know who loves free server time? People that steal credit cards, because they need to validate them against the Delta API. So here we are building accounts, but it's happening very slowly. Right? This isn't all at once kind of stuff. This is, I'm going to jump in, run my 2 hours of timeout, leave, come back in a long time from now. 2 accounts a week. That's not very much. So being able to hold the count is important. Being able to identify this traffic is important. These do not look like real users, right? Now, sure, they could probably pattern it up and make it look a little bit more like a real user. But if that's what you can catch them on, catch them. Throw the stuff away. Here's a group of flows that have data flowing across them. Look at this. 4, 4, 4, 4, 4, 4, 4. Anybody have a guess what's happening? Somebody's running a scanner, and this scanner is trying these things 4 times, right? And I know it's a scanner because it's trying to get API docs, API dash docs. It's trying to get device associations, geofences, Jira, libs, right? I can tell it's a scanner somebody's running against this thing. So once you see that there's something happening on here, now I have to take action against it. And I'll be willing to bet if you were to look at the IP addresses on there, they'd all be the same because they're running a scanner. And that makes it easier to block. So if you count things that are happening in your environment, you can use analytics against them to know things. And that's really the important piece. I can count all I want. It's doing that comparison and saying, well, Bob's tried to log in 28 times from all these IP addresses using all these different passwords. That's an account takeover attack. It's very easy to see, and it kind of leaps off the page. Now, I've talked about credential stuffing a lot, right? Because credential stuffing, in my opinion, is the real problem. A lot of these account takeover attacks and these kinds of attacks happen because they're trying to log in as you or someone else. So know where your transactions are coming in. Is it the login flow? Is it available through Nginx or whatever? IP reputation scoring is another thing that can help you, right? Is this a new IP address? Is this an old IP address? Is this a set-top box in Vietnam that's hitting me right now? You really can understand things from that. And then just simply counting the number of login attempts and comparing each one of those to different IP addresses is going to give you a ton of data about how things are working. So how do you stop credential stuffing? Well, CAPTCHAs, right? That used to be the thing. Throw a CAPTCHA at it. This Ars Technica article that I read, I don't know, September 27th. So that wasn't too long ago, like a month ago. AI bots can now identify 100%. How many of you have ever failed one of these? The AI is better than you. It's 100% accurate. See, I never know. Is that the motorcycle? I never know. A lot of times it's crosswalks and there'll be stairs and it just doesn't understand, right? This story comes from here. I was watching the flows on a third-party retail fulfillment app. I don't know if you guys have noticed anymore. If you order something online, the email you get kind of looks like the other company when you ordered something online. It looks very similar. The tracking buttons are in the same place and all. That's because there's a third-party company that facilitates all that. And so I was watching the information flow across this company, and I started to see a pattern in this request matrix that was coming through. There was about 1,500 requests per day, should say per day, for the last 90 days, for 3 months. How many of you have bought something that it took 3 months to get to you? That's not a thing, right? Well, maybe it is if you have something bespoke built, right? But if you go to Foot Locker or JD Sports or anywhere and buy something, it's probably not going to be 3 months before you get it. All of these things we're asking, the requests were coming in asking for order status. And what had happened is they were in Adelaide and they don't have FedEx there. They have DHL or something else as their last mile carrier. And so when it would go from handoff from FedEx or whoever to this local carrier, the statuses changed. So rather than saying I delivered it, it would say complete. And this guy had turned a bot on to see where his shoes were that he had bought, and it wouldn't give him status, shipped or whatever. It was saying complete, and it didn't match the algorithm that he had. And he just kept banging away on this thing, trying to figure out where his shoes were. He got the shoes 3 days after the sale. I went through the tracker and found it, right? So the shoe bot is just running around trying to figure out where my shoes are, and they'd already purchased them. But what I got from this was 2 things. I figured out how their bot worked, right? But I also figured out that they were buying the shoes. And so we could take those addresses back to the companies and say, next type sale, block this address. And they want to shut them down. Why is it important? Does anybody understand why shoe companies don't like bots to buy their shoes? They're getting paid anyway, right? Why would they care? It has to do with when you go on Twitter and go, I can't believe the bots bought all the shoes again, right? If you do that, the shoe companies get mad. And then the shoe companies go to their retailers and say, if you solve this problem, you can sell more shoes. I'll give you more allocation, right? And when they do, they do. It's really interesting. Multiple IPs were asking for the same tracking number, so he was rotating through a proxy service. Anybody here use a VPN on their laptop or their phone that's free? You ever read the terms and conditions on a free VPN? Because it says you're now part of their proxy network that they sell to botters. So your phone looks like a really good IP address if I'm doing comparisons, right? But you're just a proxy node. So the idea here is if you want to stop this kind of behavior, there should be a drop dead, right? The order shipped, this tracking number doesn't work anymore, drop dead, right? Make it so that you give signal back to the botter so they'll stop pounding on your site to figure out what's out there, right? When you have the analytics in front of you, you can take all of those items that you understand and you can apply them. So like that big event with the 5 million requests, we saw that jump off the page because that was an odd amount of traffic at that time. And so we dug into it to figure out what it was. Should you take action on a new endpoint if one just shows up, right? When V27 shows up for your logins, do you care about it? This is the kind of stuff that you have to get yourself prepared for in order to set the analytics up. If you want to understand more about this, I'll be upstairs in the lockpicking area. I'm also lockpicking today. And I can talk you through some of the analytical strategies that I've seen work best in the past, as well as some of the things that make it easier for you to do things like identifier APIs and stuff that's out there. So I hope I didn't run too short. Like I said, when my house blew up, my brain started working weird and I can't time things anymore. But I think I'm between you and lunch. So bon appetit. Thanks, guys.